this video is for Chem 2045. We're doing problems for exam number 3, and this is from the Fall 2009 exam. We're going to do practice problem number 12. This problem says the root mean square velocity of a gas molecule is, and it gives us 5 different choices to look at, and we need to figure out which one is true. There may be more than one, but the first one says the root mean square velocity of a gas molecule is inversely proportional to its kinetic energy. And we know kinetic energy to be equal to 1/2 times the mass times the squared average velocity. So in shorthand, this would be 1/2 mv squared. The first part claimed that the root mean square velocity is inversely proportional, but we see here that it's actually proportional as a square. So part 1 is not true. Part 2 says that the root mean square velocity is directly proportional to the gas constant R. We have our root mean square velocity equation up here, and we see that R is inside the square root symbol. So we see that the root mean square speed is proportional to the square root of R, but our choice says directly proportional to the gas constant. We see that this is a square root of the gas constant, so answer choice 2 is also incorrect. Mark that off here. The third one says that it's directly proportional to the square root of its temperature in Kelvin. Looking at this equation again, we see that root mean square speed is proportional to the square root of T. And that choice said directly proportional to the square root of temperature. And that's what we found right here. So answer choice 3 is true. Now the fourth one says that it's inversely proportional to the square root of its mass. To pick out the mass in this equation, we see that we have molecular weight. Well, molecular weight in this problem is going to be in units of, that's what this parentheses around the equal sign, of kilograms per mole. This is in kilograms instead of grams because the gas constant up here is in kilograms, so that's why we use kilograms just for molecular weight here. So we see that this is the mass that the problem is talking about, and because it's on the bottom part right here, we'll have root mean square speed proportional to the square root of 1 over the mass per mole. Now if we remove just the mole part, we can also say that root mean square speed is proportional to square root of 1 over mass, which means that it's proportional to the square root, 1 over the square root of mass, because this is just square root of 1 over the square root of mass. So we see that the root mean square speed is in fact inversely proportional to the square root of mass. So that makes number 4 true. Now the last one says that it's directly proportional to the square root of its mass. Now this is saying the same thing as number 4, except that it's directly proportional. So since we found here that it's inversely proportional to the square root of mass, we know that number 5 can't be true. So number 5 is also false. So our answer choice is going to be D, where it says that number 3 and number 4 are indeed true. So what you need to know from this problem is the equation for root mean square speed and how to relate it to each of these pieces, and to know what kinetic energy is.